Alright, so today in geometry we are going to work on surface area of cylinders and cones. So you will notice that the cones have a similar shape to the pyramids that we worked with. However, we do have a formula that we will use for our cones, and we have a slightly different formula that we will look at as we get to our cylinders as well. So for our cones, similar to the pyramid, we actually need the slant height, which is represented by that cursive L. Okay, so we need our slant height, which is the lateral face of the cone, compared to actually needing the height. Okay, our formula does not have the actual height. No height in the actual formula. So in the case of 24 here, or this x, we don't actually need that information for finding the surface area of the cone. We need the lateral height. So that's very similar to what we saw on our pyramids. So these first two problems, just a quick review, making sure we remember how to find that lateral height if we don't know it, or being able to find the actual height. So Pythagorean theorem, you guys should be pretty good at this by now. We've got 18 and 24 as our two short sides. So 18 squared plus 24 squared, so I can find my x squared. 18 squared plus 24 squared together, you get 900. And the square root of 900 is 30. So if you are not given the lateral height, you can quickly do Pythagorean theorem to figure that out. And then if for some reason you would need to find the actual height, 15 is one short side, x is the other short side. So we've got x squared plus 15 squared equals 39 squared. When you square those out, 15 squared is 225, 39 squared, 1521. Subtract over your 225, so x squared is 1296, and then once you square root that, you should get a nice answer of 36 inches. So quick review of Pythagorean theorem right there, just to get you comfortable with what you'll be looking at on these cones. So again, we do not need the actual height for the surface area of a cone. We need that lateral height. We need that slant height, okay? The lateral face. Alright, so for number 3, our cone gives us our radius, which is part that we need for our formula, and it gives us our slant height. We do not know the actual height, which is fine. We don't need it for our formula. So just like we did on our other surface area problems, just kind of break it down into its two pieces. Okay, you can always do them separately and then put them together for your final surface area answer. Alright, so for our first part of our surface area, which is the lateral area, we need pi r L, and pi r is 15, lateral area is 39. So when I multiply those together, I'm just going to leave it in terms of pi for now. So 15 times 39 should give you 585 pi. There's our lateral area. And then for the base, well, the base of our cone is a circle, so it makes sense that we're using the area of a circle formula that we've seen before, pi r squared. So pi times the radius, which is 15 squared, gives me 225 pi. So now I can take my 225 and my 585 and put those together to get an answer in terms of pi. That's 810 pi inches squared. And if you wanted to put that into your calculator to get the decimal answer, it would be approximately 2,544.7 inches squared. So pretty straightforward. Wasn't a whole lot extra we had to do on that one other than just making sure the correct values got into the correct spot in the equation. Okay, so pretty straightforward on that one. Number 4, you do notice that they give us the height, but we are missing the slant height. Okay, so we're missing the piece that we need for our formulas. So one extra step of running your Pythagorean theorem. So we've got 18 and 24, and we need to figure out x. Now, to save us just a little bit of time, I recognize that 3 times 6 gives me 18, and 4 times 6 gives me 24. So I know this is going to be a 3, 4, 5 triangle. Okay, so 3 times 6 was 18, 4 times 6 is 24, so I just got them multiplied by 6, which means 5 times 6 for my third side is going to be 30. So just saving us a little bit of time there. There's one of those 3, 4, 5 triangles, so we don't have to necessarily work out the Pythagorean theorem. Okay, so 30 for our slant height. And then again, we can go ahead and use our 30 and our 18, our 24. We don't need any more to find our surface area. So lateral area first part of the formula, pi r L. So r in this one is 18, and the lateral face, or the slant height that we just found, is 30. So multiply those together, just leave it in terms of pi. We get 540 pi for the lateral. And then the base, again, our base is just a circle, so we have to use pi r squared. Radius, again, is 18. 18 squared is 324 pi. So we can put together our 324 and our 540. So total surface area in terms of pi is 864. And as a decimal, approximately 2,714.3. So there's your two different types of problems that you'll see for finding the entire surface area of your cone. So hopefully those seem pretty straightforward to you, and those formulas are on your pink cheat sheet, so you have access to those. You just have to remember which formula goes with which shape. Okay. All right. So number 5 and number 6 are just a little bit different. If you notice in the instructions, they both say no base. So essentially on these, we just don't have to add in that base portion. We will just be doing the lateral area. We don't need to do the base on these. So I will do number 5 with you, make sure you're good there, and then I'll let you give number 6 a shot on your own in just a second. So number 5, again, we've got our height of 12, the actual height, and we've got our radius, but we do not have the slant height. We do not have the slant height. We'll need to find that. But again, just to save us a little bit of time, we had our special triangle earlier, the 3, 4, 5. Well, this is our other special triangle, 5, 12, 13. Anytime your two short sides are 5 and 12, your long side ends up being 13. Okay, so you could do Pythagorean theorem to check that. So 5, 12, 13, special triangle there. So again, we are only worrying about the lateral area, which in turn will be our total surface area. So pi RL, R is 5, L is 13, 5 times 13. So in terms of pi, 65 pi feet squared, which is approximately 204.2 as your decimal. Alright, so on 6, you need to figure out the radius. You need to figure out the radius. It is upside down, so 6 right here, from the bottom to the top, that's your height, and then it gives you your slant height, but you don't know the radius. So you're going to have to run Pythagorean theorem to find the radius before you can start finding the surface area. So go ahead, pause the video, take a few minutes, work this one on your own. Alright, so hopefully for number 6, you were able to find your radius is 8. Your radius is 8, and this was again one of your 3, 4, 5. Everything is just doubled, but one of your 3, 4, 5 triangles. Okay, so radius was 8, plugged it in, got your surface area. Since there's no base, total surface area is just the sides of 80 pi meters squared, or as a decimal, approximately 251.3. Okay, so there's a couple of each type of problem that you might see for examples if you need to go back and look at them for your homework. Okay, so now we are going to switch gears. We're going to switch gears and look at a few problems involving cylinders. Okay, so for the cylinder equation, instead of that slant height, that cursive L, now we have the H. Okay, on a cylinder we're going to have an actual height, okay, because they're straight up and down on the sides. So for the cylinder, we still have the radius, and then the height that they give you, usually represented on the outside, is the height that will go into your formula. So lateral area is 2 pi RH. That's your formula that basically takes care of your sides. And then compared to our cone, we have now a base on the top and a base on the bottom. So 2 bases, which means I had to take my circle area formula, pi r squared, and just multiply that by 2. So same idea as what we just did for our cone. We're just going to take those each piece one at a time. So find the lateral area, find the area of our 2 bases, and then we can put them together. So what's nice about these cylinders is they really kind of have to give you all of your information. It's kind of difficult for us to figure out the height or figure out the radius. So these usually tend to be a little less work as far as not having to deal with Pythagorean theorem. Alright, so on number 7, I'm just going to go ahead and start with my lateral area portion, 2 pi RH. So 2 pi, my r is 5, my radius is 5, and then my height is 8. So if I multiply everything together and just leave it in terms of pi, 2 times 5 is 10, times 8 is 80 pi for my lateral area. And then for my bases, because I have 2 of them, 2 pi r squared. Again, r is 5. And if I leave that in terms of pi and simplify it, 5 squared is 25. And if I double that, I get 50. So my bases are 50 pi. So together, 80 and 50. 80 and 50 gives me 130 pi feet squared, or as a decimal, approximately 408.4. Okay, same thing for number 8. Same thing for number 8. They give us our radius of 4 and our height of 10. So we have everything we need. So starting off with our lateral area, 2 pi RH. R is 4, H is 10. If I multiply those and simplify and just leave it in terms of pi, 2 times 4 is 8, times 10 is 80, so this one actually comes out to be 80 pi as well for the lateral area, even though the radius and height were different from number 7. And then for our bases, 2 pi r squared is our formula. R is 4. 4 squared is 16, and 16 times 2 is 32 pi. So together, 32 and 80 give me 112 pi meters squared, which is approximately 351.9 as our decimal. So hopefully you guys are okay on those. You're seeing where all of our numbers are coming from, how they're getting plugged into the formula there. Alright, so number 9 in the instructions says no top. Says no top, so essentially rather than having 2 pi r squared, we're just going to eliminate that 2. We don't have 2 of them anymore, so we're just going to eliminate that. And then on 10, it says we have no bases whatsoever. So this is similar to that cone where we're just going to eliminate everything that has to deal with the bases. All we're going to have is our lateral area. So I will work number 9 with you, and then I will let you guys do number 10 on your own here in a second. So for number 9, I have no top. I just have one base that I will have to worry about here in a second. So for the lateral area, 2 pi RH, R is 2, and H is 8. So simplified, 2 times 2 is 4, times 8 is 32 pi. And then, again, we just have one base this time. So just pi r squared, not 2 of them, just 1. So pi times 2 squared, 2 times 2 is 4. So 4 pi, 32 pi, and 4 pi together, 36 pi centimeters squared, which is a decimal, approximately 113.1. Alright, so go ahead, take a second, pause the video, work on number 10 on your own. Just remember number 10 has no bases at all, so you are just pretty much doing the lateral area only on number 10. Get that one taken care of. Okay, so for number 10, just doing the lateral area essentially, 2 pi RH gave you 300 pi, or approximately 942.5 for your decimal answer. So one problem you can come back and look at with only one base. Another problem if you need to come back and look at it with no bases, just that lateral area there. Alright, so hopefully you guys feel like you have a pretty good idea of how these problems work. You're comfortable with what numbers you need, where they go into your equation. So now, if we flip over onto the back, 11 and 12 are our composite figures. Okay, we're just putting a cone on top of our cylinder, or our cylinder on top of our cone. So with these, kind of doing the same thing that we've done with our other composites. We just want to do one piece at a time, one shape at a time. So for the cone, we've got its lateral area. We're really only worrying about the sides of the cone. The cylinder, we're worrying about the sides. And then we have the base that it's sitting on. Between the cone and the cylinder is open. You can kind of think of this as being like a shed or a grain bin or something, where there's not actually another base there. So I'm just going to break it down by my cone and my cylinder and my base. And it's the same way with number 12. Okay, it's the same way with number 12, it's just upside down. So on number 11, for my cylinder, I've got my radius and my height. I've got the two things that I need, so I'm good to go there. But on my cone, I've got the height and the radius. Well, for a cone, I know I'm going to need that slant height. Okay, I'm going to need the slant height for the cone, and I don't have that. So first thing I need to do is take care of that before I start worrying about my surface area. Well, again, we've had this triangle already, 6, 8, 10. There's that special triangle, so I'm not going to write out the Pythagorean theorem for that one again. We did that one earlier, so there's a 6, 8, 10. Now we have our lateral area, so we can figure out the surface area. So I'm going to start off with that cone, and this is kind of how I keep my work organized. So the cone, I need the formula for just the lateral area of that cone, which is pi r L. So I can plug in my r, which is 6, and my L, which is 10. 6 times 10, I'm just going to leave it in terms of pi, so 60 pi for the cone. Then my cylinder, okay, just the lateral area for the cylinder. Try and keep it nice and separate as well. So lateral area for the cylinder, 2 pi r h, 2 pi r h, so 2 pi, again, using that 6 again, same radius, 6, but this time 7. So 12 times 7, 84 pi. And then lastly, we have our one base that it's sitting on. We have our one base that it's sitting on, so area of our circular base, so area of a circle, pi r squared. So we've got 6 squared. So our base is 36 pi. So those are all my individual pieces. So now I can put them together. 60 plus 84 plus 36. So in terms of pi, total surface area of the whole figure, 180 pi centimeters squared, which is approximately 565.5 centimeters squared. So just take your time, break it down piece by piece, make sure you've got the correct formula, and these don't end up being too difficult of problems, okay? So I am going to let you guys give 12 a try. I just want to point out that you have your height of your cylinder, your slant height, and then your actual height. So you are missing the radius. You're missing the radius, and you need the radius for both formulas. So that's got to be your first priority, to find your radius. So x and 21 are your short sides. 29 is your long side. So you can run Pythagorean theorem real quick to find your x, and then set up your problem like we did on 11, finding your surface area. So go ahead and pause the video and take a few minutes to work on number 12. Alright, so hopefully you got 20 for your radius. Should have got 20 for your radius. Then surface area of the cone is 580 pi. The cylinder is 800 pi. And then your base, your one base, is 400 pi. So together, 1780 pi meters squared, or approximately 5,592 meters squared. So a couple of composite problems there. These are pretty common to put together just because we have learned them in the same lesson. So you will continue to see these composite problems as well throughout the rest of this chapter. Alright, so last problem, we've got a word problem, and on word problems I always recommend drawing pictures so you can kind of see it. So it says, Mathland is a small town. The water tower is a cylinder that is 300 feet tall and has a radius of 15 feet. So I'm going to go ahead and draw that cylinder real quick, just like on my pictures earlier. Make sure that I can see where my radius is and where my height is. So it doesn't have to be anything fancy. There's my cylinder. It says radius is 15 feet, so I'm just going to draw a radius, 15 feet, and then the height is 300 feet. Okay, so just a quick sketch so we can see where our numbers are at. Susie is planning to paint the water tower hot pink to make the neighboring town of Englishland jealous. Okay, so how many square feet will Susie have to paint? So, thinking about this, obviously she's going to paint all of the sides. Okay, that's our lateral area. She's going to paint the top, but she's not going to paint the bottom. Okay, it's sitting on the ground. Obviously, she's not going to paint the bottom. So this would be a problem where we'll just need our lateral area plus one base. We won't do two bases since the other one's on the ground. Okay, so just like we did earlier, starting with the lateral area, two pi r h. R is 15. H is 300. So multiply those together. 2 times 15 times 300 in terms of pi should give you 9,000 pi. Oops. And then we have one base, just the one base. So pi r squared for our one circle. Radius is 15. So 15 squared is 225 pi. So together, our 9,000 and our 225, 9,225 pi, and this is in feet squared, which is approximately 28,981.2 feet squared. Okay, so for all the other problems, I will likely accept your answer as in terms of pi or as a decimal. It doesn't particularly matter to me unless they give you two blanks for both answers. But for this problem, in order to continue going through part B and part C, we actually need that decimal answer. This in terms of pi answer isn't going to work out. So we do need that decimal answer to continue with this problem. So part B says if each gallon of paint can cover 325 square feet, how many gallons should she buy? So we need to take our total square footage that we need to paint and divide it by that 325. So 28,981.2 feet squared divided by 325 feet squared gives us 89.2 about, which we can't buy partial gallons, so she's going to have to buy 90 gallons of paint to cover that whole water tower. 90 gallons to cover that whole water tower. And then lastly, if each gallon of paint costs $30, how much will it cost her to paint the water tower? So 90 gallons times $30 for each gallon gives her a total of $2,700 to paint the entire water tower. Alright, so that's the end of our notes today over 9-4. You've got your homework assignment to start working on, and it's very, very similar to your notes, just a few extra problems, but should look very similar to your notes. If you have any questions or you need help on something, make sure you come and see me.